Hi, my name is Abby Smith, and for this video, we're going to go over the learning brain, Chapter 2, the developing brain. When babies are born, they have all the brain cells they will ever have, which is about 100 billion. Here is the baby's brain. This excludes the brain cells that are in the cerebellum and hippocampus. And here you can see that the cerebellum is the structure of the brain that kind of has the lines in it, and the hippocampus is above it, and it's that blob, well, it looks like a blob in this picture, in the middle, with a line pointing to it. These cells come after the baby is born, and during this time, the wiring between neurons changes, which causes a development. Short fibers connect neurons close to each other, and long fibers connect neurons far apart. And then you can see here, this is a neuron, and the dendrites are the part, they kind of look like tree limbs coming out down here. And then there's kind of this long stretch, and that's the axon. Neurogenesis starts off with the division of stem cells. These are stem cells, and these cells provide new cells in the brain. This is a picture of the stem cells dividing into two. This division gives rise to other stem cells, neurons, or support cells according to the book. So these neurons migrate away from stem cells. So here is a picture of neurons migrating away from the stem cells. The cells that perform active connections will stay alive while the other half dies. In this picture, I have circled in red where there is a synapse between two neurons, which I will explain to you next. So here we have two neurons. One is up here, and one is right here. In red, I have circled the synapse junction. That's the space in between the two neurons where the synapse happens. One neuron's axon, which would be right here, this axon right here, connects to another neuron's dendrites. And the dendrites are right here. And that's what I told you is kind of like tree limbs. When an action potential occurs in the first neuron, neurotransmitters are released from the axon terminal and are received by receptors from the dendrites on the second neuron. Educational groups are suggesting that children begin to learn languages, advanced math, logic, and music as early as they can. Some parents hothouse their children. This is when they use different learning tools to teach their children to read, learn languages, math, etc. So this is a picture I drew to kind of illustrate what hothousing, what parents are trying to do when they hothouse their children. And that's like teaching them the alphabet when they're like just a newborn baby, or teaching their baby to divide numbers, or even teaching them to speak another language. 3 different research findings have impacted this controversial topic of early start education. During infancy, there's major increases in the number of connections between brain cells. Critical periods are when experience shapes the development of the brain. Enriched environments make more connections possible to form in the brain than those that are not. Synaptic density, which is when the brain forms new connections, increases during infancy. This is showing synaptic density. There is a connection right there where there's a synapse. Synaptogenesis happens. This is when dendrites grow on nerve cells and synapses sprout next to them. This is showing the dendrites getting bigger from here to here. Synaptic pruning occurs. This is when connections that are not used or as strong as others will be eliminated. So if this connection in this synapse is not as strong as others, that will be eliminated. Most research comes from the human visual cortex. That's the red right here. The human visual cortex handles planning actions, selecting and inhibiting responses, controlling emotions, and decision making. There is a large increase in synaptic connections at 2 to 3 months until 8 to 10 months. From 10 months until age 10, it declines, then it stays level throughout the rest of life. Sensory experiences must occur by certain ages for the brain to develop to its fullest potential. Visual, movement, and memory functions coincide with brain development. Usually they are functions learned naturally before schooling takes place. In school, that's where we learn to read, write, and do math. The exact explanation of how we learn in relation to synaptogenesis is unknown, but there are assumptions. It is believed that when we learn from teachers, the connections are formed in our brain with synapses, like these right here. These happen in our brain when we're learning. The question at the end of the chapter is, Should a baby's environment be specially manipulated to make it richer than it is normally? That's what's stated in the book, that normal is better. Food for thought from this chapter. Don't deprive your brain, but do not overdo it. Hothousing has not been proven to be beneficial. Vitamins, again, not too few, but not too many, are important. Sensitive periods. We need to pay attention to when they are and make sure that what needs to happen in the sensitive period will happen. Thank you for watching my video. I hope you enjoyed it, and I hope you learned something or thought about it in a different way. Also, many of my sentences came directly from the book, The Learning Brain, and it very closely followed it, because it is hard to reword science and how things happen, but I hope you enjoyed Chapter 2 of The Learning Brain. Thank you.